Okay, so we are on the last bit of notes. It's air masses and fronts. Please look for the left-hand side that says weather, winds, air fronts, cold and warm. Please look for those with high and low pressure. The question, how do air mass flow from high areas of high pressure to low pressure, causing a change in weather? How does the weather change as a result of different air masses colliding? How can the weather be predicted with probabilistic ranges? So we're going to flip on over to the anticipation guide. We're going to look at 9 and 10. Those are on the bottom. Those are the last ones. Remember, 2 faults on the right-hand side, or sorry, the left-hand side, the before side. And so number 9, fronts are clouds that do not mix. When these clouds collide, storms and changeable weather like rain occur. True or false? Number 10, thunderstorms occur because clouds collide. True or false? All right, so weather. Weather is a mix of events happening in a specific area, like right around us, occurring each day due to changes in pressure. So we've looked at wind. Wind is caused by the uneven heating of Earth's surfaces. And because of those uneven heatings, you get wind. And wind also includes pressure, like air pressure. And because the air pressure differs, that causes the wind to go faster. And with those, you can have pressures hitting pressures, causing weather, rain, precipitation. All right, so air pressure, like I was just talking about, wind is air molecules in motion moving from areas of high to low pressure. One of the ways I was talking to you guys, I said high-low, like hello, high-low. It goes from high to low. That's one way to remember it. One of the things you got to know is, yes, there is pressure. Air is made up of elements, and elements have different densities, and air, thus air, can have different densities. The more dense it is, the heavier it is. The less dense it is, the lighter it is, the higher it goes. And because of this, you have pressure systems going from high, heavy, to low, light. And in a high air pressure system, what you're going to see, this just signifies this is airflow, is that the higher pressure, it sinks, it goes down. As it goes down and out and up and around, down and out, up and around. It's counterclockwise, right? And you'll notice it's nice and happy. Highs are happy. Happy. You're happy to be outside when it's sunny, bright, beautiful, clear blue skies. Whereas low pressures are lousy. And so in this, because it's low, less dense, they tend to rise up. And as they rise up, they cool down, they form clouds, and then it goes down again, and it goes around and up. So it goes up, out, and in. Whereas high goes out, up, then in. It goes the exact opposite. So this is a clockwise way. Low pressures, you're going to see they're lousy. It's going to be rainy. You're not going to like it. And because of all of these highs and lows, you then start to get something called an air mass. So air mass is a huge body of air that is hovering around a certain area. Because it's hovering around that certain area, it's going to start picking up characteristics. So for instance, if it is the air, a huge amount of air is over land or a continent, it can't pick up a lot of water. So it's going to have low humidity. It's going to be dry. But a different air mass that is hovering, say, over the ocean has a bunch of water it can pick up. So that is probably going to be moist or wet. The temperature also affects. So the higher you are in near the poles, the more cold it's going to be. The closer to the equator, the warmer it's going to be. These are all air masses, and you can see right here, we've got some air masses. So some tropicals, some polars, Arctic, very, very cold, dry. Okay, and you did see right here, you start to see these things called fronts. What is a front? Well, a front is the boundary between each of those air masses. So when you're looking at this, the boundary between these two right here, the boundary between those two right there. that boundary is called a front. And the masses don't mix. They don't, like the warm, dry does not mix with the cool, wet. They don't mix up. But when they collide, when they hit each other, that's when you get storms and changeable weather. All right, so the first type of front, there are 4 types. The first type is a cold front. This occurs when cold air is coming in. So whatever the front is, it's whatever that mass, that bunch of air is behind it, what temperature it's going to be. So a cold is more dense. It's got more oomph to it. So it comes in and it's taking over a warm air mass. Warm air mass is less dense. Think of it like a feather, where the cold air is a bowling ball. It's going to bulldoze right over it. These cold fronts, because they move so fast, because they're dense and they can push the warm air out of the way real quick, you tend to get a lot, heavy storms, precipitation, rain, thunderstorms. That's when it, like the real quick storms, that's what happens when a cold front comes through. What you're going to see on a weather map is this down here. You're going to see a line with blue triangles. Think of like icicles, blue, cherry, blue, cold, icicles, teeth. And it's pointing the direction of the movement. So you're going to see these for cold fronts. This is what a cold front would look like, where all the cold air is coming in. And you're going to have that storm, real quick storms. They don't last all day. And the warm air is getting pushed up and out. Part of that is because you have that warm air getting pushed up and out, causing clouds, which cause precipitation, condensation, and precipitation to occur. And it happens really, really fast. Warm fronts, on the other hand, warm air is coming in. But because warm air, think of it as that feather again, that feather is trying to push out that bowling ball. It can happen. It's going to take a while, but it can happen. And as it's pushing out, it rides up on top of that cold air, so that warm air is starting to cool, forming clouds, which does precipitation. This you're going to see like days of light rain. It's like constant rain, days of it. That's when a warm front is coming through. And they don't stop coming through. That warm front doesn't stop until the next one comes and gets rid of it. So this is a warm front. You can see all that warm air is going up, and it's causing a very long line of clouds and rain, and it pushes out the cold air. All right, so then we have this thing called an occluded front. This is when warm air mass gets caught in between 2 cold fronts. So you first have the warm front, which is pushing out that cold air, but then a cold front is coming in behind that warm front. So eventually it'll push up that air and you'll have 2 cold fronts hitting each other. And at that spot, it's going to be severe rain, lots of rain. It is going to be horrible. What you're going to see is a purple color. I know this isn't really purple, but it's a purple color with bumps and teeth. I think I missed the warm. Yes, bumps and teeth. Sorry, the warm front is red. And you're going to see its bumps like half the sun. So on this one, you got the bumps and the teeth on the same side, and it's purple. The next one is stationary. You're going to have both red and blue, and they're going to be opposite. So occluded, they're both. You have the bump and the teeth together right next to each other. For a stationary, you have teeth and bump opposite. Okay? So stationary fronts occur when a cold and warm front meet. Neither is advancing. They're just kind of going back and forth like a tug of war game that everybody's even. If both air masses are dry, no rain. Yay, beautiful. But if there's water vapor, yeah, there's going to be rain. Okay, fun fact, you're going to want to write this. You'll notice most of the tests and the quizzes, usually for a bonus question, an extra credit question, you have something from the fun facts. So write this on a blank sheet. It should be on the other side, and on the sides, somewhere where you can get this information. So radars and weather maps are used to locate fronts with probabilistic ranges. So the things that they observe to get those radars and weather map is they look at the temperature changes. What's going on with the moisture content? How much rain is there? How much water is there? Is there a shift in wind? Which ways are the wind going? Pressure changes from high to low, low to high. cloud and precipitation patterns. All of that gets used to predict the weather that is coming. So all the meteorologists use all this information so that they can predict the upcoming or the next set of weather. All right, quiz time. Get out a piece of paper. This is quiz 5. I put air masses. 1, 2, 3, 4, 5. So the number 1, identify this front right here and the kind of weather that's probably will bring. So looking at this, you're going to look for front. You're going to look what is coming in. At the moment, you have cold air coming in. So it's got to be a cold front. It's either A or D. And look at what's there. Is it sunny or is it rainy? Possible storms with heavy rain. Number 2, a large volume of air that has nearly the same temperature and humidity throughout that whole huge body of air at different locations at the same altitude. What is this called? Is it front, air pressure, air mass, or density difference? So it's a large volume of air, a huge body of air that has roughly the same temperature and humidity. That's going to be an air mass. Okay, number 3, an area with high pressure will result in what possible weather? Highs are happy, clear blue skies. Number 4, a warm front colliding with a cold front with water vapor in it. The warm front results in what type of weather? So this is where you have that warm pushing up on that cold. This one is going to be rain until another air mass advances. Number 5, all of the following statements are true except which? Fronts are boundaries of air masses. Fronts mix with air masses. Air masses carry a variety of humidity and temperature and air pressure. Or air moves from areas of high to low. So let's look. What are the correct ones? Which ones are right? Fronts are boundaries of air masses. Correct. Yeah. Fronts tell you what the air mass is behind it. They mix with the air masses to tell you what the next air mass is going to be. And then air moves from high to low, high-low. The one you're left with is air masses, those big ones. They don't have a variety of humidity and temperature or air pressure. They're all relatively the same. That's why they're an air mass. All right, let's flip back to the anticipation guide and look at number 9. Fronts are clouds that do not mix. When these clouds collide, storm and changeable weather, like rain, occur. True or false? On the right-hand side. This one's going to be false. It's not fronts or clouds. Fronts are boundaries that do not mix. When these boundaries collide, storms and changeable weather occurs. Thunderstorms occur because clouds collide. This is going to be false. Thunderstorms occur when a cold front approaches a warm front. That's when you have all this thunderstorms. All right, let's go back to the summary. How do air masses flow from high to low? Air moves from high pressure to low pressure. That's pretty much it. When a cold front overtakes a warm front, thunderstorms occur. When a warm front meets a cold front, days of rain occur. By observing air pressure, temperature changes, wind speeds, clouds, amount of water, and all of that can be used to predict what weather's coming. All right, that's the end of the notes. If you have any questions, please feel free to ask, and I hope you guys have a nice day.